All right, let's finish this up in Chapter 6, Unit 1 here on how to use the calculator. Is my data normal, right? How do we use the calculator to figure out whether or not the data that we have is normal, so that we could even use the normal distributions and things like that. So it is one thing to assume that data is normal, but when we actually have data models, we should see if it is or isn't normal. And one method is to look at a histogram and see, is it unimodal, is it symmetric, is it bell-shaped? Another method is to ask whether the data roughly follows that 68, 95, 99.7 rule. Both of these methods might work well with a fairly large data set. However, there's a specialized tool called the normal probability plot that will work with any size data set, which is great. This plots the data on one axis against the z-score one would expect if the data were exactly normal on that data, and if the data come back, it will be a diagonal straight line. So if you want to pause the video and write that down, here's pulse rates, right? So your job is to plug those pulse rates into your list. You recall the data on pulse rates. In one histogram, they appear symmetric and unimodal. In another, they appear somewhat uniform. Might we consider these data as having some form possibly, or they could be from a normal model? Maybe. So you go into list 1, second, Y, to turn on your stat plots. And once you're there, select the correct plot. You want the normal probability plot. It's the last one. The very last one. There's 6. The very last one. Use the right arrow to move it so that you can find it. Notice that you have a choice of having the data on either the X or Y. It doesn't matter which one you choose to do the normal probability plot. Many statistical packages put the data on the X. Many different textbooks say put the data on the Y-axis. It really doesn't matter, but you have a choice of 3 marks for each data set. Right there it is. Turn it on. That's the one you want to highlight. You put everything in list 1. You can put it on either one you want. You can put it on any mark that you want. Zoom 9 displays the graph. There it is. It looks roughly symmetric because it's going in a nice straight line. These data could indeed be considered to have some type of normal distribution. We also see an indication of I believe it is granularity in the plot, excuse me. That is because we have several data values that occur several times in the same overlapping area. Okay, but we'll be able to use the normal model with that. I know that was quick, and I could have tried to plug that in. When the videos get to be over 13, 14 minutes long, it starts to lag a little bit, even for you guys. So this is just a nice little quick recap on just how you would do normal probability plots. But now that you know how to do that with your data set, now you would know that you could then do a normal distribution with it as well. So that helps with the calculator, and now it's going to dive in with some examples so you can see how to use them.